Hey there, and welcome. Have you ever wished you could predict the future? I'm not talking about a crystal ball, but using data you probably already have sitting right on your computer. Well, that is exactly what we're going to dive into. We're talking about something called regression analysis, and it's this super powerful way to find patterns and make forecasts all inside a program you definitely already know, Microsoft Excel. So here's the game plan for today. We're going to start with the big why, like why is predicting things so important anyway? Then we'll break down what regression actually is, and just as crucial, how to know if our predictions are any good. After that, we get our hands dirty. I'll show you how to unlock the tool you need in Excel, we'll run our very first analysis together, and finally we'll learn how to read those results and turn all those numbers into real, actual answers.
All right, so first things first, why even bother trying to predict the future? Well, especially in business, being able to make a smart, educated guess about what's around the corner is basically a superpower. It's what helps you figure out how much stock to buy, where to put your money, and, just make smarter decisions that can really be the difference between success and failure.
To make this all feel a bit more real, let's just pretend we're running a company. A really common question we might have is, hey, if I change the price of my product or spend more on ads, can I predict how much more I'll sell? This is the perfect kind of question that regression analysis was born to answer. Okay, so we've got our question. How do we actually find that connection between sales, price, and ads in our data? Well, this is where regression analysis comes in to save the day. You can pretty much think of it as a statistical detective that's designed to sniff out the hidden patterns for us. The specific tool we're going to use is called linear regression. And yeah, there's a little bit of jargon here, but I promise it's easy. The thing we're trying to predict, in our case, quantity sold, is what we call the dependent variable. It makes sense, right? Sales depend on other things. And those other things, price and advertising, are our independent variables. They're the things we can control and change to see what happens. But honestly, let's just forget all the fancy words for a minute. Picture this. You take all your sales data and throw it onto a chart. It would probably look like a big cloud of dots, right? All regression does is find the one single best-fitting straight line that cuts right through that cloud. And that line, that becomes our prediction machine. Okay, so we've got a line. Big deal. Anybody can draw a line through a bunch of dots. The real question is, how do we know if our line is any good? How do we know if we can actually trust its predictions? Well, to do that, we need to look at a couple of really important numbers. The very first number we want to look for tells us how well our line fits our data. And in our example, that number is 0.962. Now, I know it just kind of looks like a random decimal, but trust me, this little number tells us a huge story about our model. So what is it actually saying? This number is called R squared, and the easiest way to get it is to just think of it as a percentage. So an R squared of 0.962 means that a whopping 96% of the reasons why our sales go up or down can be explained by our price and our ad spending. That is an incredible fit. The rule here is super simple. The closer this number is to 1, the better your model is. Okay, the next number we've got to check has a bit of a scary sounding name, significance F. But don't worry, the idea behind it is really straightforward. The easiest way to think about it is this. It's the probability that our entire model is totally bogus, that any patterns it found were just a complete fluke. So naturally, we want the probability of our model being bogus to be as tiny as possible, right? The magic number, the sort of industry standard, is 0.05. You want your significance F to be less than that. And if we look at our model's number, it's 0.001. That's way below the line, which is fantastic news for us. It means our results are legit. So for this one, just remember, smaller is always better. Now, a quick but really important side note. In your results, you're also going to see something called adjusted R squared. You can think of this as the smarter cousin of the regular R squared. And here's why. R squared has this weird habit of always going up when you add more variables, even if those variables are completely useless. Adjusted R squared is a lot more honest. It only goes up if a new variable actually makes the model better at predicting. So when you have more than one independent variable, like we do, it's usually the one you want to pay more attention to. All right, enough with the theory. Let's get practical and actually do this thing in Excel. The tool we need is called the Analysis Tool Pack, and it's built right in, but for some reason, it's usually turned off by default. So our first mission is to go find it and switch it on. Okay, ready? Here's how you do it. First, you're going to click on File, then go all the way down and click on Options. A new window will pop up. On the left side, find and click Add-ins. Now, look down at the very bottom where it says Manage. Just make sure Excel add-ins is selected in that box and click Go. And I promise, one last little window. Just find Analysis Tool Pack, check the box next to it, and hit OK. And boom, you've just unlocked a new superpower in Excel. So now that we've enabled the tool pack, you're going to see a brand new button on your data tab. We are ready to roll, and you're not going to believe how fast this next part is. Head on over to the Data tab in Excel, and way over on the right, you should now see a button that says Data Analysis. Give that a click. A list pops up. Just scroll down to find Regression, select it, and click OK. Now this next box looks a bit intimidating, but you only have to tell it two main things. First, the input Y range. The Y is always the thing you're trying to predict. For us, that's our sales column. Second is the input X range. The X is all the stuff you're using to make the prediction. For us, that's price and advertising. Just select both of those columns. Then just click OK, and Excel does all the hard math for you in less than a second. And just like that, Excel creates a brand new sheet filled with results. Now, I have to be honest, the first time you see this, it can look like a giant wall of numbers. It can be a little overwhelming, but here's the good news. We can pretty much ignore most of it. We just need to zoom in on those few key pieces of information that we've already talked about. So, here's all the important stuff pulled out from that table. We can spot our R-square and our significance F right away, and we already know how to interpret them. They tell us our model is a really good fit and it's reliable. The new pieces of the puzzle are down at the bottom, in the coefficient section. These numbers are the secret ingredients for our prediction formula. The intercept is our baseline, and the other numbers tell us the exact impact that price and advertising have on our sales. So let's just do a quick final check. Is the model good? Yep, R-square is super high. Is it reliable? Yep, significance F is super low. So what's the last piece of the puzzle? Well, it's building the actual prediction formula that we came here for in the first place. And there it is. We literally just take the numbers from that coefficient section and plug them into the simple equation. This right here, this is our data-driven crystal ball. We now have a formula where we can plug in any price, any advertising budget, and it will give us a seriously solid prediction of our future sales. How awesome is that? So what does this formula actually tell us in plain English? Well, that -835 next to price means that for every single dollar we increase the price, we can expect sales to drop by about 835 units. And the 0.59 next to advertising tells us that for every dollar we spend on ads, we can expect to sell about 0.6 more units. See, this isn't just numbers on a page. This is actionable intelligence you can use to run your business. So just think about what we just did. We started with a simple business question, and we ended up with a powerful, data-driven formula that can help us forecast the future. This isn't about being a math genius. It's about using the tools you already have to make smarter decisions. You now have the key to unlock predictions from your own data. So the only real question left is, what are you going to predict first?